Real quick, in this session, before we get started, we're going to be doing the Passive House Slam Dance. We're going to be discussing all things Passive House and some different and creative approaches to achieving Passive House certification. Now, we'll also discuss what the HERS Rater's role is in doing this and achieving that certification, and why it's important to work early and often with a rater to be successful, either in Passive House or any work that you do. And before we get started, a membership spotlight. Our member, R Value Homes, was recently featured on the ResNet Builder of the Month blog. R Value is a net zero and green builder right here in West Michigan. So please read through the owner, Jake's comments on the importance of the ResNet HERS ratings for homes on the ResNet blog, which you can check out at that short link there on our website. Now, you know, this is what Green Home Institute members do. This is who Green Home Institute members are, and so can you. So consider becoming a member, going to our website and learning more. I also want to thank today's sponsor, our silver level sponsor, Panasonic. Panasonic offers ventilation solutions for healthier homes and all ventilation needs, all the way from a supply only, all the way up to demand controlled energy recovery ventilation and everything in between. I've personally been using Panasonic for many years in all my homes and helping keep my family safe and healthy with fresher air. They have Energy Star certified inline fans or exhaust fans to meet the baseline ventilation requirements, or set up continuous intermittent exhaust to comply with various standards. They have energy recovery ventilators going all the way up to 200 CFM, both decentral and central systems, and they have cold climate ones as well that keep on working when it gets cold. These paired with demand-controlled air quality sensors mean they only ramp up when pollution is detected and are much more energy efficient. So check them out over at greenhomeinstitute.org/Panasonic ventilation. All right, again, we'll welcome everyone to Passive House Slam Dance. This course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. This course is approved for multiple continuing education units, including our Certified Green Home Professional designation with at least 3 pillars: energy, health, and materials. It's also approved for AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Make sure you look for the 5-digit FIAS code that will be sent out for Certified Passive House continuing education. So with that, I'm going to hand it off to our speakers today and briefly introduce them, but they'll introduce themselves. First up, we have Neil Goldman here with us today for the first time, and Shannon Pendleton, who's been a longtime member and recently on the show. So welcome back, Shannon. It's great to see you again and have you on the show. So I'll hand it off to both of you. Welcome, and please take it away.
Awesome. Thank you so much for the introduction, Brett, and the opportunity to be here. I'm going to share my screen and get us started. So let me know if you can see that all right.
Yep.
Great. Thank you. So, looks like my window moved. There we go. I'm Shannon Pendleton, and I lead Passive House projects at Sanderson Sustainable Design in New Hope, PA. And I'm excited to be here with Neil Goldman of Less Energy in Philadelphia, and to talk about Passive House. We've both worked in this space in different roles for a long time. Currently, I do design, project management, owner's rep, and consultation. I'm an online host with Passive House Accelerators Construction Tech and the in-house Passive House consultant at Source 2050's High Performance Marketplace. And I also volunteer a lot, which is a great way to get involved. And most notably with Green Building United in Philadelphia, which is where Neil and I met. I'm also a proud GHI member. So Neil has an amazing path too. Neil, you were at Kitchen and Associates when we met, is that right?
Yeah, that was a while ago, but I was a HERS rater for Kitchen Associates. There's a larger architecture firm focused on affordable housing. So yeah, I did a lot of more multifamily housing projects there. Um, yeah. Um, yeah, so I also was able to do a 25 unit passive house certified project when I was working at Kitchen as well. So I've been working on this stuff for quite a while. And since then, I had moved into the construction world. So I was a construction project manager with Habitat for Humanity, which we actually worked on that project with Green Building United together to sort of analyze Habitat's ability to be able to go to passive house. And then I also worked on some high-end residential construction projects as a project manager, so I was able to work on passive houses projects from the builder side. So I've had quite a lot of experience as well.
And now you run your own firm. Exactly. Yeah. So
Right.
uh, we are excited for you guys to ask questions. So please drop them in the chat and we will share our LinkedIn so you can connect with us and reach out anytime. So why passive house slam dance, right? Well, even as high performance becomes code, architecture to me and passive house can feel pretty punk rock compared to business as usual. And it can easily get disorganized and turn into an out and out mosh pit. So Neil and I want to share with you how to crowd surf and stay above those flying elbows and share some tips and tricks we use to keep it fun. So first of all, when you talk about passive house, the best example you can show is how it's becoming code in Massachusetts, or any graph on passive house or the energy transition that looks like a hockey stick and represents nearly $1,200 billion in global investments. There's a lot of data out there, and Google is now your friend. It used to be harder to find, now it's pretty easy. Second, it helps to share that globally, passive house is either at the top of a step code on the path to zero energy, or at the base code, and no other way is possible, on the path to zero carbon. So globally, there's over 1,200 certified projects and over 120,000 projects that are using the principles. But the most compelling thing you can do is show how passive house is just great design. So in all of our work, our projects either use the principles or push for certification, or both. And any project can be a passive house, whether it's a retrofit, new construction, residential, commercial, high-rise, multifamily, single family. And if you're going to certify, you can do that with FIAS, which is Passive House Institute US, or FEE, which is Passive House International. But both certifications really use 5 simple principles to yield 12 benefits and gain 70 to 90% less energy with a proven return on investment. So we really like to focus on the health, safety, and welfare, and how passive house has the best indoor air quality and comfort of any building out there. It's very asthma friendly. It's noise canceling, so New Yorkers love it because it keeps the honking cars out. It's free of dust, bugs, drafts, and moisture. It's all electric and off-grid friendly. And in many cases, it's been proven to be wildfire smoke resistant. So when you're offering passive house to your clients, first figure out what they value and why passive house delivers that better than any other methodology or certification. As Michael Ingui says of Passive House Accelerator, nobody ever wants the house with the dust and the bugs and the drafts and the moisture. So that image in blue in the center of this slide is not a vacant building. It's a passive house seen through an infrared camera in winter, next to the ones that are letting all of the heat out. So best of all, passive house focuses on how excellence is measured. It's not the architect or builder saying it's great. It's a third-party rater or verifier proving how the work measures up. So it's your client's best guarantee and insurance that they are going to get what they pay for. So when you think about modeling your workflow and your proposal, think about it as a waltz. You're going to go through rounds of review with your team and the certification body as the project marches forward. So share and track your scope of work at every meeting. so your whole team knows what to expect and when to lead and when they're expected to follow or review. And ideally, for certification, you'll register the project during schematic design, receive pre-certification on that design at the end of design development, and go for final certification during construction documentation and administration. Also, let your client know that other team members may be needed because Passive House is a team sport. At the very least, make sure your team has a CPHC or a Passive House designer, a verifier, and a mechanical engineer. Now, often, if you're doing a residential project, you might not have a mechanical engineer, but you're going to need one if you do Passive House because you're going to add ventilation and you want to make sure that that ventilation is balanced. If your owner has a builder, ask them to include pre-construction services in that builder's scope of work so that they can get paid to join the design meetings. They are going to be critical for your sequencing conversations and in understanding what materials you want to specify. And then plan a great kickoff meeting and get everyone on your team to attend that kickoff meeting. During that kickoff, do introductions, let everyone introduce themselves, review the project mission, all the Passive House requirements, your scope of work, and then review the project documents that you have to date. Share your initial design recommendations on the form factor and the orientation. It also helps to have a roadmap and a schedule, share some case studies that are similar, and take questions. We find our best practices is to pair an experienced member on the team with a newbie and either do that internally in your office or make it a requirement of the RFP for professionals that you want to add to the team. We also find that sweet spot for hosting that kickoff meeting is right at the end of schematic design.
Hey,
So
Shannon,
yeah.
Real quick question. For Passive House, is it actually mandatory to do that preliminary rating pre-construction plan review with the organization? And so like, let's say you get through halfway through construction or you're done and built and you miss that window, but you meet all the goals. Are you still certifiable or is that a mandatory thing?
Yeah, you could do this in the background and not talk about it and not share it with your team. You don't have to do a kickoff meeting.
Oh, no, sorry, not the kickoff meeting, but the approval from the Passive House body of your plans and everything. Is that a requirement before you start building? Like, it sounds like a great idea. Is it required?
No, it is not required.
Okay.
But it's a really good practice because let's say you do your design, you start to build your building, you get your permit documents, and then you go to certify, and the certifying body flags something. They say, hey, this doesn't look right. This looks like a moisture risk or, something else. Then you have to go back into the design process and redo documents, hold more meetings, and those are usually additional services. So it's really cost effective to do it early.
Yeah. Thank you.
Thanks for asking. Absolutely. So we certify with FIAS. They have two paths for certifying, Core and FIAS Zero, and both of those lead to optimal results. So for FIAS Core, it's typically new construction, and it can follow either a prescriptive or a performance path. And for FIAS Zero, they're combining Core's passive conservation limits on space conditioning, and they are then adding active conservation source energy targets for the user loads, like lighting, appliances, and mechanical systems. And then they add a layer of a requirement for renewable energy, whether that's on-site or off-site generation, or whether you're sourcing your renewable energy from renewable resources. For the core prescriptive path, it's pretty simple. You use FIAS's climate map and calculators. You set targets for R values and system efficiencies. Excuse me. And for the performance path, you chart a path to be renewable with the core limits on heating and cooling demands and peak loads, or you level up to FIAS Zero. And you can choose which one of those that you can hit with your team as you go through the process. and then get that net energy use on an annual basis. So real quickly, we're going to jump into a couple case studies, and we can look at these more in depth later. But first, we're going to look at a project named Silver Green. It's a completed multifamily project. It was prefabricated, and it achieved Source Zero Passive House through FIAS. Our client had multiple future goals that we had to make specific. So we started with narratives from all the team members and then put numeric targets on those narratives to measure our success. Some of the client goals included how to swap out systems in the future without damaging the passive house envelope, how to prepare for community solar, and a planned renovation after 20 years of occupancy to create an event space for the community. Those are just a few of the goals. There were many. But we worked through all the assemblies and transitions in the envelope on the exterior. I think I might have missed a slide there. Yeah, sorry. We worked through all the assemblies and transitions in the envelope on the exterior, which included a full stone veneer and wood fiber insulation. And then on the interior and how those parts would go together, which included 2 airtight wood burning fireplaces, which required dedicated air intakes and exhausts in order to isolate them from the balanced airflows for heating, cooling, and ventilation on the passive house envelope. So always review your air barrier strategy and any thermal bridges that you think you might run into in your building envelope. Put little circles around that full building section and say, hey, these look like they might pose a moisture risk. So let's talk about them and see if we can mitigate them. And if FIAS flags them, we might have to do hygrothermal models on them, which is what you see on the bottom of this. These were the hygrothermal models we had to do at 3 different locations where FIAS said, oh, looks like you might have a moisture risk. So we modeled it out. So when in doubt, model it out. As soon as your geometry is set, create a systems diagram. And if available, model those systems in 3D so that you can clash detect your ductwork. Always use gasketed penetrations if you can for easy future swap outs. And have a power strategy for your current power and your future on-site generation. And if you can, invest a few pennies to run conduit to your property lines and not just your roof and your shutoffs for future solar. Then you can also be future-proofed for maybe community solar. So while you're digging up the earth, while you're building everything, it's just pennies on the dollar to run that conduit. And it makes it very easy to upgrade in the future without having to do any demolition. The next case study I want to look at is called Kabunja. It's a project Neil and I are working on together, and it's still under design. It's looking to achieve FIAS Core or Source Zero Passive House certification. So this is where we defined the climate set first. We picked our climate and looked at the orientation and site. We did an initial WUFI model with the design as is in schematic design. And as you can see, there's a navigation tree in WUFI where if you look right here, there's all of these wonderful areas of the building, attached zones and systems where you add all of your components, and then it gives you the status and results of those components, and it gives you the visualization of the geometry, and it gives you the input and output dialogue for where you're meeting, exceeding, or are under the targets for passive house certification. So this little heavy dash line at the 5 here, between the 7 and the 8 here, between the 4 and the 5 here, and right outside the 3 here are our heating demand, cooling demand, heating load, and cooling load targets. And you can see all of our results are under those targets. So right away, we looked at the geometry and we made a quick recommendation that the area here in yellow, which was an indentation in the form, be brought out to the face of the form, because it was creating complexity and sequencing issues for the air barrier and adding cost. Every time you have a corner, you add cost to construction. And this was another little area where they had an outdoor balcony that was eroded from the form. And so we said, hey, you know, we think we can add square footage, reduce cost, and improve efficiency. So how about bringing these form areas out to the face of the facade? So they did that, and we modeled in version 1, the old version, and then the improved version. And you can see with that form factor improved and the assemblies going from more general to more specific, our energy demands and our loads were both reduced. So you can see how close we were to the heating demand in version 1 and how much further we are from it in version 2. And then we also showed at the base how far we are just from FIAS core. If we're just going to FIAS core, because here's our source energy criteria. You know, in our first model, we were about 5,600 kilowatt hours per person per year. In our second model, we brought that down to about 8 when it came time to deliver right here. And that equates to about 400 watt solar panels. And if we wanted to go for 0, about 400 watt panels.
Now, Shannon, do you see a benefit here? It looks like you've got some buffer built in, right? So you're kind of going further below the requirements of the model. Is there like a benefit to doing that also in the sense that perhaps you get through construction and maybe it didn't shake out the way you had hoped, something was a little less efficient, right? We hope the builders are going to do a great job. They're going to build it better, but we all know sometimes there's a deficiency. Is there a good to have a buffer so that if there is a deficiency, you know, you still make it? Is that part of the thinking too?
Absolutely. And I have never seen a project that went exactly as planned.
Right.
You know, you may meet your schedule, you may meet your budget, you may go under or over, but it will always be different than you planned. You know, the Suez Canal gets blocked. Your materials can't show up. You've got to substitute. Okay, what are you going to use? How thick is it going to be? And what's it going to do to your energy model? And so building in buffer and telling the team where you're building in buffer while you're doing that energy modeling is great, because it helps them understand, hey, you know, if we have to squeeze the mechanicals because we can't afford them and use a lesser mechanical system, then, you know, our windows are going to protect us in this area. Everywhere you add buffer, you decrease the need somewhere else. And everywhere you increase, you know, the need somewhere else, you pull from the buffer. So it's like a big seesaw where all of this whole building system operates together in tandem. So this is a quick summary of the envelope assemblies that we recommended. Initially, in orange over here, we just recommended target R values with our base model. And then when we got more specific and we started to build those assemblies out and layer those assemblies and derate them for any structure that might be moving through the continuous insulation, et cetera, we put dimensions on them. And we started to name names and started to name materials so we could understand our vapor profile. Is our assembly going to dry out to both sides and be bidirectionally vapor open? Or is it only going to be able to dry out to one side because we're using a closed cell foam? And what does that do to certification? What rules will we have to follow if we go to a single vapor profile and we only dry out to one side? And have those discussions, because ultimately you want your team, when they leave this project, to do this again and to feel comfortable knowing why they did what they did and how to go forward. So for instance, on this project, here's a great example of highlighting that WFI model on the slab, what that assembly looks like, what it looks like graphically in the model, and some of the product recommendations that we made for EPS, XPS foams, and air barriers below those, above that insulation and below the slab. That climate-friendly XPS and that mineral wool insulation on the interior of the slab, on the walls below grade, same kind of story. So if you want to be vague and not name names, you can do that. But if you've got your builder on board, they usually have a supplier and they want to talk about that. So don't be afraid to have those conversations if they're appropriate. And don't be afraid to be general and just give target dimensions and R values and allow the builder to find those materials. For above grade walls, we looked at going bidirectionally vapor open and using wood fiber wherever possible. So we have a wood board, a wood fill, and the option for wood bat insulation in our assembly. And we're talking about long-term R value, fire resistance, carbon smart technologies, moisture management, sound dampening, and how insulation might settle in the structure and where that might be okay in some assemblies and where it's not okay in others. And, how much nicer it is to install a product like that. For the roof, I should have highlighted the roof on this one, but you do see the assembly is shown here. And we're using a vented roof assembly. We talked about whether or not we wanted to use a vented assembly or an unvented assembly and how a vented assembly would increase the warranty on the products and also keep the heat off of the insulation and improve our assembly's ability to deliver that passive house comfort. For the windows and doors, we ran through 3 different manufacturers and talked about which ones might be more appropriate than others. We always like to use a pre-certified window unit because all the metrics are then available for the things we need to put in the model, like the U value of the mounted window, the frame factor, the U value of the glass alone, any solar heat gain coefficient we might apply to that glass in order to prevent overheating, or any kind of shading we might need on certain elevations at different times of year. Same goes for heating and cooling and ventilation. We have a strategy. We block out what zones we're going to have, where we're going to put our mechanical rooms, and what kind of equipment we want to look at. For hot water, same story. Pick your appliances, talk about how you're going to do the layouts. For this house, it's a really big house. We talked about distributing vertically in 2 areas with 2 different zones and tying those together with a horizontal pipe with a shutoff so that if one system goes down, you can open up that valve, serve the whole house while you repair the system that's down and not lose any functionality. That was a great tip I got from a friend, Stephen Basic, on the Build Show. And everybody went, yeah, that's a great idea. Let's do that. So speaking of which, passive house is way better with friends. So have a buddy system. Don't be the only sole person on your team. Make sure you pair experience with someone new so that you get there faster, and share what you're doing in your community, volunteer, and get involved and meet the other people who are interested in what you're interested in. And with that, I am going to hand it off to Neil. Feel free to throw any questions you have in the chat. Thanks.
Hey everyone, sorry, I was on mute there. Thanks, Shannon. That was great. So quickly today, I'm going to go over what a HERS rater is, what a HERS rating is, and sort of what the HERS rater's role in the whole process is. I'm going to talk about how Passive House uses other energy efficiency ratings to sort of roll up into the big certification, but you end up getting 3 other certifications along the way. One of those is Indoor Air Plus. So I'm going to talk about some of the indoor air quality requirements that you wouldn't normally think of, but you have to plan for in a passive house. I'm going to talk a lot about the equipment that goes into a passive house, the heating, the cooling, and the ventilation equipment specifically, and sort of the different attributes, pros and cons of those systems, and why you may select one over the other, and sort of what efficiencies go with those. And then finally, I'll talk about sort of aligning build teams to the timeline that it take of the process from a rater's perspective, from the beginning all the way to submitting for the certification. So, oh, here we go. Sorry about that. So, what a HERS rater? What is a HERS rater verifier? So, a HERS rater is a person that has gone through a lot of learning and testing to become a certified HERS rater. I have a number, and I'm certified with ResNet, which is a national organization that holds certifications for HERS raters. They also oversee the National Registry of HERS rated buildings. So you could look up if you bought a house. And it has a HERS rating. You can look up on the ResNet website when that happened and all the information behind it. You don't necessarily need to have an energy efficient house to get a HERS rating. You could just, an existing home can get a HERS rating. So I'm overseen by a provider, which is someone I deal with every day. And that's where all of my certifications get sent to, and all of my energy modeling gets QA'd by. They also QA me in the field, so they'll come out, depending on how many HERS ratings I do, they'll come out and look at 10% of them, both in the field and my paperwork. So I am not just out here alone. I'm vigorously quality controlled as I quality control other buildings. And then I do a lot of different things like consulting, as you know, when I do a passive house project. We do a lot of verification in the field. So we do a lot of visual verification, pre-drywall inspections, inspections of the water management system, or air sealing measures. And I also do a lot of testing. So I'll do testing at pre-drywall, and then typically a lot at the final. We'll test the HVAC equipment, the hot water systems, the building itself. So a HERS rating is basically an energy model. It's sort of like Woofy Passive, but a lot simpler. It's not taking into account any thermal bridges or any condensation risks or anything like that. It's a very basic energy model. As I mentioned, there's a certified database of all these energy models. So if you were going to buy or sell a home, you should look to see if it has a HERS rating, and it can tell you a lot of information about the house. It can predict pretty accurately the energy use that the home will go through. It inputs all kinds of stuff, which I'll show you in a second, but everything from the building envelope, windows, its air tightness, all of its equipment and appliances, lighting, everything like that. Even the direction it faces, the color of the walls, all of that gets put into the HERS rating. It's used on for a lot of different reasons. Code compliance is a big one. There's now, in most state codes that have adopted newer energy codes, have what they call an ERI pathway. If you see that in the code, that is basically a HERS rating. They don't mention it in the code that way, but the ERI path is a HERS rating, so you could use it for code compliance. It's needed for Energy Star certification, which I do a lot of, and Zero Energy Ready Home certification. And it's also used as a tool for auditing existing homes. So I do a lot of energy audits where I'll go do a existing HERS rating of a building and can suggest updates and say, if you replace all of your windows, I can show that it'll save this much per year. So you can kind of do a quick ROI of different energy upgrades to a building. This is what the HERS rating this is what the HERS rating energy modeling software looks like. This is a screenshot from Ecotrope. So you could see there's all kinds of mechanical inputs up at the top. There's envelope and, sorry, I went backwards or forwards. The envelope, fenestration, all that information goes in here, and then it spits out the information about the energy bill, and then all of the compliance for a specific project. So Passive House has a lot of individual requirements that you've heard of, and they also have a lot of requirements that come from other programs. So you can see on this tree, and this is from the Passive House website, Passive House, as you go up this tree, incorporates all of the programs below it. So, you know, if you're going to get Energy Star certified, you're definitely going to have code compliant, right? And you can see the HERS score here. Quickly, a HERS score, I didn't mention this, is 100 is typically around code, and 0 is net zero. So as the score goes down, you're using less energy. So Energy Star is like sort of the baseline program. There's a lot of requirements. There's 5 pages of checklist requirements, and a lot goes into that. It's a great basis for starting your energy efficiency path. Indoor Air Plus adds a lot of requirements for a healthy home. As your home gets more and more airtight, they want to make sure that there's less pollutants and less risk in the home. So Indoor Air Plus is a lot about the environment inside the house. And then Zero Energy Ready, you need to get Indoor Air Plus and Energy Star certified, and they add a certain amount of requirements on top of that. And then we go into FIAS, which requires that you get Zero Energy Ready certified, which kind of goes down the line. And as you can see, this is a screenshot from the quality assurance workbook for FIAS. And on the right here, you can see where all these different requirements are coming from. So Energy Star requires you have 50 CFM enrichment in air, but Passive House requires that you supply fresh air from the ERV to all bedrooms, which Passive House does not. And this goes throughout the quality insurance workbook, and there's many requirements from all the different programs.
Neil, if you want to quick go back to the other chart there, I'm thinking about the builders who they're doing the HERS rating, they've got it down, and they understand it, right? And we can only hope to get every builder to that level, but they're thinking, if I want to go passive house, where are my HERS ratings? Where should they be landing? I mean, I'm kind of seeing here that it's really that 30 to 40 range. Can you just speak a little more to that briefly on if someone's trying to make that decision, how they might think that through before they get down the woofy path, pathway?
Yeah, sure. So, a HERS rating of it is difficult to get each point on a HERS rating. So if you're at 30, you probably are pretty good along the way of getting to passive house. But if you're struggling to get Energy Star, you may want to start being, I don't know, I guess when you're at Energy Star, you've probably done a lot of the baseline work, and you're sort of like maxing out at the typical construction strategies, right? You're using the sheathing as drywall, you're using baseline windows, 0.3, like solar heating coefficient windows and U value, and you could be using a furnace, right? And so then you sort of hit this like cliff where to go to Zero Energy Ready, you're gonna probably have to shift a lot. Like you're gonna have to go from gas burning fuel appliances that are pretty efficient to all electric, and you're gonna have to switch from exhaust only ventilation to balanced ventilation. So I think the difference between Energy Star and Zero Energy Ready Home is a big cliff. But then once you switch to all those newer technologies, you have an air barrier strategy, you have this ventilation system. It's probably easier to move along the path after that because you can add insulation here. I'm already getting good windows, but maybe I'll do a strategy where the south facing windows have less of a solar heating coefficient, right? And you're sort of dialing it in even further, but you're not making giant changes to your strategy.
Mm-hmm. And to be clear, for those who don't know, when people start adding solar, it starts knocking your HERS rating down. But these are all pre-solar numbers, correct? Like just to make that clear, you can't just add a bunch of solar and knock your number down and be on your way, right?
I mean, I guess technically you could. I mean, I think that FIAS has a bunch of like space heating and per person requirements, so maybe you couldn't do that. And you can't do that for Energy Star because they have all these other requirements based on air tightness and all these things. Straight up HERS score though, you could have 100 HERS score in a code built house and get down to 0 with all solar.
Right.
However, it wouldn't get you any certification. You wouldn't have the rest of it. You would just be creating a lot of energy.
Right. Thanks.
Yeah, I hope that helped. Okay, so we talked briefly about this, but this goes throughout the entire FIAS certification. Every piece of it sort of builds from different programs. Okay, so indoor air quality is not a program a lot of people are familiar with. And so indoor air quality, indoor air plus the certification, um, has a big section on moisture control. So they are very concerned about, once you have an airtight house, you don't want any mold risk. So they make sure that you are flashing your roof connections properly, that you're flashing your window connections to the wall properly, that you're connecting the ground to, like, kick out flashing at the bottom of where the two different materials may meet. They want to make sure that the drainage plane of the house is complete, thought about, and working very properly, so that the gutters drain away from the house and there's no chance of picking up bulk water from anywhere. Um, if you're in an area that is a radon zone higher than 1, it's interesting, in Pennsylvania, in Philadelphia, there's no radon requirement, but anywhere outside of Pennsylvania, you immediately start to have to do radon mitigation. So we're used to this, and so you either have to, pull radon from under the slab, or have a method for getting rid of the radon away from your house if you're in the proper zone. Um, for HVAC systems, they add a lot of requirements, like you need to seal up the HVAC systems from getting dusty during construction. So this is a common requirement in LEED, but this adds this here. There's ventilation requirements for when you go to commission the house. You need to ventilate it for a certain amount of time. So you want to make sure you look into those requirements. The rater will sort of bring those up in the meetings and during the process, but there is a lot of small requirements that get added with this indoor air quality plus. And the last big section of that is low emission materials. So you want to watch out for any formaldehyde in your cabinetry or carpentry or paint and sealants, and they're very specific of which ones can be used. This one's gotten a little easier over time, as a lot of that has sort of become commonplace, but you still want to look out for it. So high efficiency equipment types. Now, there are a lot of different equipment types, right? You can go all electric or fuel burning. As I mentioned before, you could get away with a fuel burning appliance in an Energy Star house. But once you start moving up that ladder and you get more and more efficient, more and airtight, and the requirements get tighter, you really need to go to all electric. So for heating and cooling systems, there are really 2 types. Well, there's only one type, right? There's a heat pump, right? Because you need to do cooling. So heat pumps come in all different shapes and sizes, right? You can get a vertical or horizontal mounted ducted heat pump that forms and acts a lot like a typical furnace in a house. People are more familiar with this, like, ducted system. And then there's split systems, so non-ducted mini splits. You typically hear them, and these days there's all different types of split systems. So you could have wall mounted, ceiling mounted, floor mounted, radiant floor systems. And then you could have one condenser that supplies 5 heads inside, or you could have one head to one condenser and have a bunch of condensers. So there's a lot that goes into a split system. And then there is electric boilers and heat pump boilers that you could do a hydronic distribution system with in a house. And I'll talk a little bit more about that. So, right, you're going to go to a heat pump, right, when you go to a more efficient house. So the decision becomes, are you going to do a ducted, non-ducted, or a hydronic? So a lot of pros with a ducted system, right? Centralized system. In a smaller house, you may only have one system, maybe 2. And so that makes, you only have one fan and one coil and one refrigerant line to manage. You don't have to worry as much about leaks. There's typically less filters to change. And this is a lot more common. So you're going to find HVAC contractors that are more familiar with installing ductwork and doing a common practice. However, big cons with ductwork, it's large, right? You need to find and plan for spaces, chases, all soffits, all kinds of stuff moving through the building to be able to fit that ductwork in there. A rater has to do the duct testing, right? And so there is a lot that goes into making an airtight duct. If the contractor isn't familiar, they have to, do a lot of masticing before they even put the thing up in the air, because they often hide a seam or something. And I'm going to come and test it, and those requirements are really tight. that also comes with air balancing, right? Passive house has very tight requirements for supplying air to different rooms. And if the ductwork isn't done well with dampers and designed to be able to be balanced with the right um, registers or all kinds of different methods, it becomes very difficult at the end to make the balancing requirements of passive house. Um, Ducted systems, while they can be zoned, they could usually be zoned like upstairs or downstairs, right? And so there is a little bit of zoning, but it's not as dialed in as a non-ducted system would be able to be zoned. So when it comes to a non-ducted system, as I just mentioned, zoning, you could put one head in every room and you could cool just the room that you're in, and the rest of the house could be warm, right? And so there's a lot of zoning benefits to having individual systems. Um, Retrofits, they're great for because you don't need to run ductwork, right? As we just said, ductwork is big, there's lots of soffits. You could typically squeeze a refrigerant line that in some of these systems can be quite small, through an inch wide pipe. And so that is a big benefit when you don't have a lot of room. Those soffits, right? Same idea. You don't have to run ductwork, so you don't have to make spaces smaller or take corners for vertical pathways. Much easier to install, right? You can just pop it on the wall. This goes to the same idea of there's not a lot of ductwork to run. They're often just mounted on the wall, or if it's a new construction situation in the floor system, or as sort of looks like a radiator. Um, these can be great for small spaces because if sometimes a ducted system, right, you can only pull back as much as possible. The capacity of it is what it is. Where with some of these ducted systems, you could get much smaller capacity into the room and really make sure the capacity for that system is correct. On the flip side of that, of course, there's capacity issues because sometimes there's either too much capacity or too little capacity when it comes to these systems, and you're on the edge of it. Like, say you need 5 heads, but the system you're looking at only has 4, so you have to go to the larger system, and then you're at a much larger capacity. So as Shannon was mentioning before, it's very important to get a you need a mechanical engineer involved in the process to be able to select these systems properly. But they do have sometimes an issue with the zoning or the capacity. Some of the other cons, long refrigerant lines, it is nice to have all these refrigerant lines running, like be able to sort of put them where you want and don't have ductwork, but at the same time, more refrigerant lines create more refrigerant, more potential for leaking, and more connections. So that's always a consideration. These things need to be able to get condensation away from them. So if you need to run a condensation pipe through the wall or with a pump, and it's always a consideration if it's below where the drain is and you need to pump it up, or if it's too long of a run, you may need to run a new drain through the house to be able to deal with the condensation. There's aesthetics that are a consideration as well, right? So you want to make sure that it looks good, and these things are on the wall or they're in the ceiling and you're always going to see them, where a register from a ductwork can end up looking much nicer. And I honestly think I made a mistake by putting zoning on the end of this, because zoning is definitely a plus for this one.
Yeah, I was wondering about that. But real quick, Neil, 2 quick questions for you and what you're seeing out there on this ducted versus non-ducted. I was just the other day anecdotally looking at a lead for homes preliminary plan review rating. They originally had a ducted air source heat pump, and then they switched it to mini splits, and all of a sudden the HERS rating just dropped, right? And for those of you who don't know, that's a good thing, right? Better HERS rating. And so I just anecdotally, are you seeing large drops when you make switches? Are you guiding people on that, or what are you seeing out there?
I think I don't see people change very often, honestly. That's an interesting point. And I wonder if
Yeah,
it's
that was
like,
rare too.
I know those, yeah, yeah. So I wonder if it's like the efficiencies were the same, or, yeah, I think that those systems can run a lot more efficiently because the
Mhm.
delivery system is efficient. And so I think there probably is a bonus in the software for having a non-ducted system, because there's
Yeah.
no leakage and there's no loss through the ductwork, because you're not worried about the duct insulation and all the insulation.
Mhm.
So,
Now,
I
also
think there
real
is
quick.
a
Oh, go ahead.
place.
Well, I was just saying, real quick too, on the and passive house is meant to be healthy, right? You pointed that out with the Indoor Plus program. Probably want to have good humidity control. I've heard some of these ductless systems might have potential humidity issues and need supplemental. What are you seeing out there?
I haven't heard that.
Okay.
I think it depends on like how you operate your house, maybe.
Okay.
And I guess that is it's it's always like a problem when these systems run too shortly. And I guess when you have a lot of capacity in a small room, it won't run long enough. It's like the short cycle problem, and it won't pull humidity out. I could see that being a problem. If the room's cooling down really quickly, but not pulling the humidity out.
Right. Thanks.
Yeah. So, um, there is a hydronic option, right? So you could have an electric heat pump boiler, um, and provide warm water running through whether it be radiators or radiant floor systems or even a fan coil system. Um, these systems can be really energy efficient because their delivery system is very efficient. You can combine them with hot water. You could have a tank, or you could use, if the load is small enough, you could use a heat pump hot water heater as your boiler and then sort of store it in a different tank and pump it around. Um, no air filters to worry about because it's all just coming from the radiant. And I find that, plumbers are used to installing boiler systems, so it's kind of an easy thing to find an installer for. Um, Now I have a question mark after no cooling because I've heard that there's systems coming over from Europe that have cooling in them. They're actually a heat pump boiler that could chill the water, deliver the water chilled to a fan coil unit that's sort of like a mini split in the room, and then cool the room as well. So I would love to see a system like that, but I don't think it's very common. So a big con of this hydronic system would be no cooling. And then depending on the house, it's tough to retrofit a radiant floor. So you'd often need to put radiators around the house, and those take up space and look a little weird. Um, yeah. So I just wanted to mention some program requirements real quick that are often a little trippy for people in the process. You need to pressure balance the rooms between one PA with respect to the rest of the house. So you have to make sure that there's a transfer grill from a bedroom or a return grill or a undercut door. And this is always a problem at a passive house, even if there is a mini split on the wall, because you're supplying ventilation air to the room. So you're going to be pressurizing the room, and you can't over pressurize it. So you have to be careful of that. And then you want to make sure that you're pulling all your exhaust from the kitchens and bathrooms. It's a requirement. Intake exhaust more than 10 feet apart. This is a common one, but sometimes it gets forgotten, and it's difficult when you get into the field. And as Shani suggested, this is great when you do a 3D drawing of all your ductwork. This gets planned out, but often you get to the field and it's hard to. It seems simple to get 10 feet apart, but often you're in a mechanical room and you're going out one side of the house and there's another floor and it's difficult. So just be careful with that one, and make sure you plan for it. Filtration minimum. This one seems simple, but you have to make sure that the system has a large enough filter to meet the requirements, which is a MERV 13. And then if it goes into like the static pressure loss. So the engineer needs to make sure that they put the right filter in the beginning. You can't just switch the filter out always at the end. So it's got to be in the design. And then supply error to be measured within 15% of the design value. Passive house design values are often in the very small amounts, like 30 to 40 CFM. So 15% of that can be 3 or 4 CFM, which I can measure that difference, but it's very difficult to balance and measure those differences. So we have to make sure that we're thinking about it and planning for the balancing. All right. So I would do the same thing for ventilation, different types of ventilation systems, different types of distribution, ERV versus HRV is always a big one, and then a few more program requirements based on ventilation. So there are 4 types of ventilation. Exhaust only is very common in the Northeast. Where I am, that's typically how most builders doing an Energy Star project. This is where they typically have a exhaust fan from the bathroom exhausting air at the right rate so that air is being pulled into the house from that exhaust fan. You get your ventilation. Supply only is better. It's the same idea. It's often a supply fan pulling air from the outside and dumping it into the return of the system so that air gets conditioned. I wouldn't suggest this typically in a colder climate. This is good in a warmer climate because you don't want to be pulling in cold air from outside, and it could cause condensation problems. And then what is required for a passive house? Oh, sorry. Well, natural ventilation is where you are able to open windows and just naturally ventilate the building. And this actually goes into the owner's model. You can say the owner naturally ventilates, and it could be included. It will get modeled that way. But balanced ventilation is typically how is required in a passive house. Not typically it is. This is where you're bringing in air and exhausting air at the same time so that the air flow is balanced. And so different types of heat recovery systems, this is where you have balanced ventilation, and so you want to recover the heat from the airflow in a way. So that's what an ERV is, energy recovery ventilator. So the difference between an ERV and an HRV is ERV is able to pick up humidity, which is important in the right climates, as it is in the Northeast. HRVs can be probably used in a drier climate, but I've actually never seen one. So I'm always in the Northeast. But there's actually two different types of, well, there's a lot of different types of ERVs, right? There's a wheel, there's a core, and then you could even have like a medium that picks up humidity and temperature. But I wanted to talk about the machine active and passive, as lately I've been seeing a lot more of these active ERV systems that use the air conditioner and the heat pump cycle to help with the ERV efficiency. So I don't know if you guys have heard of a system like a package system that does heating, cooling, and ventilating, but they're able to use the heating and cooling system to increase the efficiency of the ERV. So I just want to mention that ERV is measured in percent of heat recovery. So we typically see around between 75, 85% recovery in a passive house. So you want to look out for that. So this is a quick diagram of how a core ERV would work, one with a core. So there's two fans in here, one blowing the air one way, one blowing the air the other way. So it's pulling air from the kitchens and bathrooms and wherever there else might be a pollutant, and exchanging that outgoing air with incoming air that is fresh from outside, and that's being delivered typically to the bedrooms of the house and sometimes the living spaces. And then that exchange is able to exchange the heat going in and out of the house. So two ways to typically two different kinds of distribution systems for a ERV system. So there's sort of a centralized home run system where there's one big ERV. It's got a manifold that runs supply air to each place it's supplying, goes right back to the system. So sort of like a manifold system for plumbing, you can dial in each branch that is going to each room, making balancing very simple and making testing and install simple, because typically the ductwork is much smaller. You use like 3-inch ductwork that's flexible, that can be run around through the whole house instead of having to knock together all of the square or round regular ductwork. The problems with this, are maybe only 1 or 2 companies that make it, and it can be quite expensive. And it also needs kind of a big space. In my experience, they're larger and need a dedicated room, where I often see the other type of ducted ventilation systems be put in a closet, and they're kind of thin and small, as we saw in some of those photos in the beginning. So some of the pros of a traditionally ducted ventilation system, this is where the whole thing is hard piped all the way through like a regular HVAC system. Whether, for a passive house, you need to supply all the air to the bedrooms, but in an Energy Star or Zero Energy Ready home, you could dump that supply air into the HVAC system to be conditioned. So, familiar to local installers, a lot of HVAC contractors can install these types of systems. They're much easier because they're traditionally ducted. There are a lot more people that are making these types of ERVs, much simpler because they don't have the manifold, and it can be integrated into the HVAC distribution. Like I said, more than that, they can be controlled by the HVAC system. So if while it's running, it may tell the ERV to run, or vice versa. When the ERV runs a third of an hour, it's telling the HVAC system to turn on as well and condition that air that it's dumping into the return. Balancing is a big deal in passive house, and I brought it up several times, but these types of systems can be difficult to balance. I've experienced a lot of heartache in the field having to install dampers later or install different types of registers. They make self-balancing registers that are a little better, but it all can be quite difficult towards the end. Larger ductwork, like I said, the manifold system type kind of has 3-inch ductwork. These are going to have 4 6-inch ductwork and be larger and more expensive to install. And sometimes they require the HVAC system to be running a lot more than it normally would because it's using that system to distribute the air. I just quickly wanted to talk about these packaged magic box systems that are becoming more popular, as I mentioned. They can be really good for small projects because you install this one ducted system and that's it. There's only one distribution system, not a separate ventilation and cooling system or heating and cooling system. They use the ventilation air to pull in outside air to be able to, cool or heat the coil down. So they don't need an outside compressor, which can help a lot with outdoor space. And because they have these active heat recovery systems, they can be very efficient at heat recovery. Again, not a very common system, unfortunately. These I've only seen a few. You can get them, but there's longer lead times and not as common. And then they do have some restraints where they won't be able to do all the things that individual systems will be able to do at the same time. So as I meant, it uses the ventilation air as the compressor, but it can't ventilate and condition the space at the same time. So it's sort of switching back and forth sometimes. This is a slide I've seen already. So quickly about lighting domestic appliance requirements. For a passive house, 80% of the lighting needs to be Energy Star qualified, which can, hinder some lighting selections. All appliances, dishwashers, ovens, well, not ovens, but refrigerators, washer and dryers, all need to be Energy Star certified. And the hot water system needs to be efficient in delivery. So I measure how much hot water will come out of the furthest tap from the hot water system, and it needs to raise 10 degrees before a half a gallon of water comes out. So it definitely needs to be thought about and planned an efficient system so that you're not waiting forever for hot water to come out. And finally, aligning the build teams is a big one. So, I'm going to talk about design review, sort of the different processes that we go through as service raters. So often in the beginning of the process, we're brought in, we're working with China right now on the project we just mentioned. Well, so that we sit through a lot of the meetings to make sure that as things sort of get hammered out, the requirements and the different field things are thought of. Once the design gets put together, I'll do a review and make sure all the requirements not only are thought about, but like end up in the document so that at the end, the builder understands their responsibilities. Once the process gets started, I do a pre-construction meeting, whether it's an Energy Star project or a FIAS project. I want to make sure that anybody that's going to install anything having to do with the certification is going to be at this meeting. And we all sit around and talk about what, who is going to be doing the air sealing around the electric wire penetrations that the electrician's going to make. Sometimes it's the electrician, sometimes it's a separate air barrier installer. So you just want to hammer those things out. Who's going to, the ventilation ductwork needs to pass through here, but the HVAC guy thought he was going to use that for his trunk duct. So you have to make sure all those things are coordinated, and you go over the timeline and all the different trade responsibilities. It's really important meeting. During the process, I continuously communicate with the build team and design team and make sure that all the requirements are being met and they plan for the different things that we've talked about. And then the last big thing is testing before drywall. I come out and do a pre-drywall inspection, and so this is the sort of the timeline of events for hosting process. And we talked about pre-construction meeting. I come out for a slab and foundation installation inspection, and then the pre-drywall inspection is like the big one in the middle. So I'll do a lot of visual inspections, but it's also important, if you can at that time, to do a preliminary blower door test and duct testing if you can. And that's when you typically find all the small problems. Did this penetration didn't work, or this air barrier has a hole in it in the middle because of manufacturing. I'll bring smoke out and we'll, find all the little holes so that we're sure at the end we're going to meet the requirements. Towards the end, or, right as the building is reaching substantial completion, I want the building to be like almost complete, painted, all the switch plates on, everything ready to go. I come and do all the final testing. Floor door duct leakage, balancing. I measure the watt draw of the ventilation equipment. I take thermal images. There's a lot that happens at that final inspection. And then finally, I compile everything, complete the HERS model, checklist, and then do all the program submissions for certification.
Neil, at what point in this process are you communicating any kind of passive house issues so that the WUFI models are also getting updated if you run into anything or see it, or do they just know how to draw that out of your HERS reports, like during a pre-drywall inspection?
I think that, so I'm verifying, right, that like, okay, you said you were going to put R60 in the attic, and I measure and I say, yeah, okay, you're actually 2 inches short, so you have R56. I'll typically communicate that back to the modelers so that they know that my field verification, we're sort of aligned on those things.
Thanks.
Yeah. So I do create a lot of field reports that I share with everybody. This is from the Passive House Quality Assurance Workbook. So this is all the information I need to fill out for the blower door test. We do 2, 1 in depressurization, 1 in pressurization, and do an average result. And then this is what the report from the ventilation system looks like. So I am reporting what the design values are, what the verified value are, what the total values are, the difference between this 2 different things. And as I was saying, there's a lot that goes into the balancing of the ventilation system. And that is all I have. Thank you, guys. Great.
Well, great. Thanks, Neil. Let's go ahead and start jumping into some of the questions here.
I've been working hard in the background, Brett, to try to answer all of the Q&A ones, but excited to hear if people have more.
Yeah, yeah.
There's one there from Chris Snyder just for Neil, so Neil, jump in.
Yeah, there were some great questions, and I definitely am going to bring them up and highlight them as well. So certainly. Real quick before we get into those questions, just a reminder to you all that yes, this session is being recorded, and you can go to our YouTube channel in the next couple of days and see it there for availability. You can go ahead and click subscribe right now, and you'll get an instant update when it is available. And then for those of you watching this session on demand in the future, but not right now, take your quiz with an 80% passing rate and you'll receive your continuing ed certificate. For those of you who are here right now, as long as you've been here for the entire CEU hour, in the next couple of days, check your spam for certs at gutenbergcerts.com to receive your certificate. If you're AIA, fill out that survey. so you can get your AIA submitted as well. And before we get into all those questions, again, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our members, over 300 of them, and our top tier sponsors like Build Equinox and Panasonic and many others who are making products to help attain Passive House and do it in a more sustainable and affordable way. So yeah, just to real quick here, the question that came up to you, Neil, was you know, if you're working with a potential client who, again, and this is going off the earlier one I asked you, is used to the HERS rating, and I want to give this question to you too, Shannon, but who's working with the HERS rating and they're used to that, and perhaps the commenter is saying there are some deficiencies within the HERS rating that are not associated within the passive house modeling tools, like I've heard in the past. Hydrothermic flows in the ground doesn't get accounted for in HERS in any way. How are you communicating that there are these potential deficiencies and they need to watch out for that? I mean, that's kind of their main question. So I'll kick it to you, Neil, and then Shannon, maybe you can follow up with that. So,
I haven't run into that too much. Typically, I rely when I do a passive house project, it's typically, the passive house modeler is communicating a lot with the client, and the HERS model is sort of just in the background, and not too many people are aware that it's even happening. So I haven't had to describe those efficiencies too much, but I guess I would, if I needed to, if they came up, I would mention it. But it doesn't seem, I don't know. I guess I would just rely on the passive house modeler to explain those things. I don't know.
Yeah, it doesn't really come up. People don't typically ask me either, Neil. So I'm with you there. And that chart you showed where, the FIAS has that performance staircase and where the HERS results, fall into line with those, I think is really helpful. But in terms of ground contact and the things that, are different between the two, it's really question by question. And, for the ground contact question, I say, we model that in WFI. So, we'll assign a property to the area of the building that's in contact with the ground. And then WFI will know, oh, I have to calculate this area for ground contact. If it's only exposed to the outer air, same thing. Or if it's adiabatic, like a party wall between two townhomes, same thing. We're really just drilling down on the properties and all of the geometries and whether they're opaque or transparent, and what zone they're in and what they're in contact with.
So I'm going to kind of merge two questions here. And the first one is, what is the difference in cost of compliance versus, so maybe it's a soft cost versus hard cost, right? So your soft costs, your consultation fees, your rater fees, your certification fees, versus the actual hard costs. And I guess maybe the answer is, right, where are you coming from, right? As Neil, you showed that chart, that step up ladder. Are you coming from Energy Star? Are you coming from HERS? Are you coming from code? So I'm going to just expand on their question a little bit, knowing, hey, part of that is the answer. So what are the costs to build better to passive house, maybe above code? Let's ask it that way. And someone else asked, at least they claimed their clients are building to passive house certifiable, but not getting certified. So why should they get certified? What is the benefit? So kind of adding that certification question around costs and why do it,
Absolutely. Neil, if you don't mind, I'll jump in and then you can add.
Sure.
Typically when I have a client who's wondering whether to certify or not, I say, go for certification, because it's the best way to ensure you're getting what you paid for. Mm-hmm. The cost is relative to the square footage of the project. And also if it's an affordable multifamily or a single family. And then where you're located in your climate zone will require, maybe you need more insulation because you're in the Arctic and you need like those special windows that are ZNC Arctic level. Maybe all you really need is a windbreaker with a zipper and to get airtight, and you really don't need a whole lot of insulation because you're in a hot, humid climate. But your cooling efficiency is wicked important. The short story is the only way to know what it's going to cost you for the soft cost is to reach out to your certifying body, get an estimate, share it with your homeowner, and say to them, of all the choices that you're going to make on this building, which you're going to have over 800 choices typically when you build a home, you're going to make choices that have to do with aesthetics, that have to do with performance, that have to do with comfort. This is one of the least expensive choices you're going to make, and it's going to ensure your health, your safety, and your ability to go off grid or drift and be safe if the power goes out for 9 days and not be subject to extreme temperature swings or wildfire smoke or the things that can threaten you now that we spend 90% of our time indoors. For the hard costs, like I said, it's really climate based and it's also choice based. So there are many off the shelf products that you can buy to get to Passive House and do very little differently in order to get to Passive House. But if you care about carbon and you care about your vapor profile being bidirectional and you are super, super nerdy and a tree hugger, you're going to go for really natural, non-toxic materials, which are a little bit harder to find and sometimes more expensive. But I help my clients understand that it isn't Passive House that makes the project more expensive. It's the choices that you're making. Houses are just expensive to build. Are you going to buy a $5,000 countertop? Or are you going to buy an ERV that's, are you going to go through Passive House and save, $5,000 on your ERV because you can downsize it or something? It's a balance of choices that you're making. It's a whole home budgeting experience, but this is the best way to understand your return on investment for the one thing you can't budget for, which is your energy costs. So if you build a typical home, your energy costs are going to fluctuate and they're only going to rise.
Thanks, Shannon. Neil, anything to kind of add to that? I mean, obviously you could also ask that same question for the HERS rating, just in general, and in the context that it plays in Passive House, costs associated with that. Why get rated,
I mean, I think certification generally to me is always about quality control, right? Like my whole role as a rater and verifier is quality control. If you're not having somebody come out there and look at the installation, I find install problems every time I go to a site, every time. It's never done perfectly. Because I stick my hand behind wall connections and find gaps, and I stick I'm poking through things and looking everywhere. And I always find problems because people are human, right? So you need quality control, right? How are you supposed to know that like someone didn't punch a giant hole in the wall before they drywalled? You got to do a blow door test. I mean, I've found so many problems, like people sheetrock over ductwork all the time. The boot of the ductwork gets sheetrocked over and then it's lost. And I've gone to sites and done the duct test, and the builder was like, "Oh my God," and didn't realize, like, the house is almost done and didn't realize it was ducted over. That happens all the time. Like every ventilation system I test is almost never flowing right when I test it, and I need to increase it or I need to figure out why it's not flowing properly. It happens. It's not like, oh, every once in a while. It's all the time. So I think the quality control is a huge piece of it. And then cost, yeah, I would agree a lot with what Shannon said. It really depends. But I mean, I think you could get an Energy Star certified house with just the cost of me coming out. Like typically the components of the house are of a quality that they can make it, but it's the quality control they want to make sure. So, there probably is, you probably could get the Passive House with a small increase if you wanted to, but it would be, you'd have to think about it a lot, right? Because you could use drywall as an air barrier if you really were careful about it. So, I think the real important question is, are you able to deliver the house for the cost that you thought you would? Are you running over in all these like unknowns?
That's
or is
the
it
big question.
predictable
That's the
cost?
biggest question.
Yeah. Because if you don't think about it and you get to the end and it's 30% more because you forgot that you had to put an ERV in, yeah, it's going to be expensive, right? But if you plan for it and you do it and it comes in on the cost you thought it would be, then it seems to make sense.
Which is another reason to add someone experienced on the team with someone new, because the first time you do it, you're going to make mistakes. You're going to fail. And that's great. That's how you learn. We've all been there. But if you have someone who's been there before, they can share the tips for doing things affordably. They can share the tricks for maximizing the free parts, the passive parts of Passive House, so that you pay less for the active parts that you're going for, whether those be the solar panels at the end or better mechanicals in the middle. But you know, having that experience pays. Oros Group in Pittsburgh did a great chart that said Passive House experience pays, something like that. You can Google it, but it really shows all of the data that came out of Philadelphia when the first multifamily passive houses were built, where they built the passive houses at cost and sometimes under cost for the multifamily affordable units they were building. And that was because they had experienced teams.
Now, you know, Debbie here pointed out again, just all, you know, so many people are attempting or going for this, you know, the technical approach to Passive House, which is good, right? We want people doing this, but, you know, not certifying. And so her question, and if you're willing to go on record, Shannon, or maybe not, because we're being recorded, but like, what is the biggest pain point, like, to get someone that maybe needs to be fixed, to get someone over that hurdle of, you know, I'm going to do it, but not certified, to now I'm getting certified? Like, have you been able to see anything like that? Is it something that can be fixed?
Oh, if someone's handing out money, that's always going to be
Sure.
effective,
Incentive.
right?
Yeah.
So if you have incentives in your state, or you can find the IIJA, IRA incentives that match up with the certification you're trying to get, that's going to help. But really, that return on investment and that safety and health factor, you can't put a price on that. And other houses don't deliver that. If you have asthma and, you know, during pollen season, you're being tortured. And when I have clients who have asthma, they go in their passive house and they leave the inhaler at the door, and they've set it on video for me, which is brilliant. And I can't think of a price I would put on that if I were an asthma sufferer.
Yeah. So another question came in. I'm going to kind of expand upon it, but the question was, you know, what are some foam-free strategies to getting to Passive House? And you know, for those of you, you know, why do that? You know, right? Obviously, potentially health concerns, right? Cost, and I think even increasingly, and maybe we can talk a little bit about embodied carbon and some of the trade-offs of embodied energy and carbon versus, you know, operational. But just, you know, answering that specific question, you know, what are some of the foam-free strategies? Can you make Passive House without foam?
You absolutely can make passive houses without foam. It's very hard to do at the foundation. So, like, I consider Passive House at the very top of all green building certifications until I look at Living Building Challenge, which is, there's so fewer of those, and it's like the holy grail of green building. Even they allow foam at the foundation because there's no great substitute. Foam-free foundations can be done, but they're just, it's hard to find a contractor who wants to do a foam-free foundation because it's kind of a risky adventure to put a fibrous material that can rot at the base of your building. It's like wearing shoes that degrade as you walk if you don't do it right. But for carbon materials, when we look at energy, whether it's embodied or operational, Passive House takes care of operational energy for us. It takes care of 70 to 90% of all of our operational energy. Those are your energy bills. But everything that you choose and put into your building as a material is embodied energy. And that means the manufacturing process, the delivery process, the construction process for putting it in, until you start to use it and all the trades have gone away. And all of that embodied energy is 50% of our 2035 and 2050 goals when we look at our global goals for climate change. So 50% is a ton. You know, when Passive House started out, we thought, great, we've got the solution. We just build a bunch of passive houses. But when you choose foam and you choose materials that are toxic, or you choose materials that are, you know, produced in an inequitable way, you're having impacts on the planet, either in terms of carbon, in terms of energy, or in terms of people. And when you talk about health, safety, and welfare, those things matter. But if you need to build affordably, you need to use foam right now, keep it outside of your air barrier as much as possible, because then you're not breathing anything that's off-gassing from it. That would be my best advice.
Seems like they're making better foams now too, right? They're
Yeah,
getting better
it's like
and better.
mushroom foam now, right?
So, and then there was a follow-up question: what ground contact information or insulation could you use instead of foam that has a similar R value? And maybe you're saying that's just hard to find, right?
Well, you can use XPS foam with better blowing agents and understand how the foam is made and what those blowing agents mean. Just
Yeah.
like you can buy mechanical equipment with better refrigerants, or maybe use mechanical equipment that uses water to transfer heat instead of cooling agents to transfer heat, or cooling. And so materials matter. And the more you learn about materials, the more there is to learn about materials. It's like wine. The more you learn about wine, the more you know you don't know anything about it. So pick what you like, do as much research as you can, and use the sites like Parsons. New School has a healthy materials lab with lots of materials on it. The International Living Future Institute has the Red List free label. If the Red List free label is on a product, it does not have any of like 700 chemicals that are bad for you. And they also have a declare label. If a product has a declare label, it may not be perfect, but at least they have the guts to declare what's in it. You know, our food didn't used to have labels on it, and we had to lobby to get that label put on so we know what was going into our body. That's what's happening now with our buildings. And your building can make you sick if you don't put the right things inside and spend all your time in there. So materials definitely matter.
So another question that came in was asking, you know, what's a better choice? Geothermal, but they mean ground source heat pumps, or PV arrays. And so I kind of want to ask that question in the context of passive house as opposed to just a general question. And, you know, as we pointed out with you, Neil, we talked about how we can't use the PV arrays just to hit these standards, right? We can't do that. And so, of course, then, you know, maybe the question I want to talk about is really ground source versus air source. Are you going to get a significant benefit to switch from air to ground to achieve your passive house targets for cost, or what are you seeing out there, Shannon?
I always think it's more expensive to dig, just because the big three costs of building any project are foundation, windows, and roof. So foundation work, and anytime you dig up the ground and do groundwork, you have potential for added costs. Plus, for all of the architects doing passive house design and construction and certifying or not certifying, they find they don't need ground source heat pumps to achieve the certification or provide comfort. And in many cases, if they put it in, it's because the homeowner thinks they want it for comfort, and then they almost never turn it on. What I see most commonly happening right now is architects will put in what's called an EMAT in bathrooms to warm up the tile on the floor, because it's a small electrical load that is intermittent, not constant, and it is satisfies the client request for comfort that they think they want. And then usually the feedback is it just doesn't get used. The biggest comfort issue that ground source heat pumps and geothermal in a building offer, in my opinion, is in cold climates where you can keep a slab warm.
Hmm.
But with passive house, if you have a certain amount of insulation under that slab, let's say you start cheating and like squeezing the model and you don't leave any buffer in and you get as little insulation as possible in that slab to certify, you might have comfort issues. So you might build in a buffer on that insulation under the slab for comfort, which then allows you to use that buffer elsewhere if you need it in the model on windows or systems and things like that.
Yeah. Now let's bring the solar back in. Like, let's say we're trying to hit the net zero target for passive house, right? And I'd assume then you're talking about a trade-off of efficiency, right? At some point you can count that solar, but maybe the ground source heat pump would, get you a little further. They both have a Inflation Reduction Act 30%, even higher tax credit if you're low income housing. So does that still hold? You would still maybe usually suggest, hey, go for more solar versus ground source, or where are you at on that?
If you live in the forest and you don't have any sunlight,
Sure.
and you don't have to take down too many trees, go for that ground source heat pump. Everyone has different opinion. I think it really is, where do you want to spend your money and where do you want to get your energy from? And do you want it to be on site? Because you can achieve source zero by buying renewable energy elsewhere and having a power purchase plan over time in order to satisfy that requirement. Now, offsets are usually, they're known as offsets, right? So they're usually like a last resort, but it's a great bridge between being able to make your own energy and having to buy your energy from somewhere else. And it also supports, those making green energy in your area.
Yeah. This has been great, and I appreciate you both staying over a little bit to continue the conversation and get to some of these questions. Real quick before we wrap up, and I'll kick it to you first, Neil, where can people go to contact you or learn more, reach out?
Oh yeah, thank you. Either on my website, lesnrg.com, or you can email me, Neil at lesnrg.com.
Great. And you, Shannon?
I dropped both of our links in the chat earlier for LinkedIn, which is usually the easiest way to follow whatever I'm reading or talking about or doing.
Sure.
But if you email Shannon at sandersondesign.net or reach out to me through Passive House Accelerator or Source 2050.
Great. Well, Shannon, Neil, thank you so much. Thank you all for joining us. Have a great rest of your week. We'll catch you on our show next week. So take care. Goodbye.
Thanks.
Thank you.
Thanks, everyone.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.